All right, doing this problem called set matrix zeros. Given an m cross n integer matrix, if an element is zero, set its entire row and column to zeros. You must do it in place. That means you have to do it in O of 1. You can't take extra space. And any of the uh, if any of the so for example here this is zero, that means the entire row and the entire column has to become zero. Okay, this is another example. In this example, this was 0, so this row and this column becomes 0, and this was 0, so this row and this column becomes 0. So I can sense the problem that can happen is you have to know the original zeros, because otherwise what happens is, let's say if with this 0, you convert this into zeros and zeros, now you don't know whether this was 0 to begin with or this was made 0 by this, right? That is something that you're not aware of. And because if you're not aware of that, then when you look at this zero, you might say, hey, I want to convert this row and this column to zero. And as a result of that, your entire matrix will just become zero. So one of the things is definitely you have to keep track of original zeros, right? Original zeros. But now you can't take extra space. You have to do it in place. And one of the ways could be, hey, can I go through the matrix? Can I find out uh, what positions are original zeros and maybe save them in a set and then go through that set, right? Just that set. And if that set says 0 0, then I will update that row and that column to all 0, and then I'll do it for each and every 0. That is one way. In that way, I get an extra space equal to the number of zeros. Now, that's one way. Is there a question about what a follow-up? A straightforward solution using O of M, and space is probably a bad idea. Yeah, that anyways. In a simple improvement uses a O of M plus N space, but it's still not the best solution. Could you devise a constant space solution? So he's asking, can we do it in a constant space? So the approach that we talked about would actually need the number of zeros. So now let's see if we can do it in place without taking any extra space at all. I mean, other than few variables maybe. So let's say we go through this, but I think what we use is we already have a lot of space in the sense that the original matrix, let's modify that original matrix to keep hints maybe. So what I mean by that is let's say I find so let's use the first row and the first column uh, as hinting guys. So let's go to whiteboard, and I'm trying to fix my mouse, but okay. Uh, so essentially, let's take an example of the first matrix. So the first matrix was 1, 1, 1, 1, 1, 1, 1, 1, and this was 0. So what we do is we go through each and every element, and in each, after going through each and every element, if I find some element as 0, then what I do is I change the row, the first the correct the first element of that row and the first element of that column as 0. And at this point, when I'm at any matrix and when I'm at a particular cell, I already have visited the first row and first column of that cell, right? So essentially, then what I do is I change this one to 0, and I change this one to 0, and then I come down. And after that, my job is I go through the first row. If there is 0, I convert that entire column to 0. Then I go to the first column. If there is any zero, then I convert that entire row to zero. And this is how I convert it. Now, is there any edge condition, any base condition that you might be missing? Let's look at the other example as well. So in the other example, the input is 0, 1, 2, 0, 3, 4, 5, 2, and 1, 3, 1, 5. Okay. I feel like this might be a corner case where your 0, 0 is a 0. Okay, but so essentially what this would mean is with my algorithm, I'll say, hey, this is 0, that means make the first row, make the essentially nothing. So the first element of the first row and first column is so it is already 0, you keep it as 0. And then when I reach this guy, that so what this means is that hey, make the first element of this row, which is this, make it 0, and the first column of this row, which is this, make it 0, which is already which it already is. Right, this is done. So now what you have to do is go through the first column, which is this. So go through the first column, which is this, and wherever you find whichever cell is 0, corresponding row make it 0. So I'll make this entire thing as 0, 0, and this is where the problem will be, because now when I go through the first row, and if this is 0, that means hey, I convert this to 0, this to 0, which is fine, and but these two zeros are zeros because of this, not because of this. Like these two should not be made 0. This should be made 0, but these shouldn't be, right? Because these have to be made zeros because of this 0 and not because of I found any 0 in the corresponding cell. Yeah, how do we distinguish that? So maybe do not handle the first row and the first column. Okay, so let's go back. Let's do this problem again. So the input was 0, 1, 2, 0, 3, 4, 5, 2, and 1, 3, 1, 5. Okay, and when I look at this 0 and when I look at this 0, essentially it means that uh, like the updating bit, when I was saying update the first row and the first cell of the row and the first cell of the column as 0, which they already are, which is fine. Now my thing was I'll go through each and every. I go to the first column first. I go to the first column, and in that first column, but I'll ignore the first row there. Okay, so nothing to change, nothing to change. Okay. No, sorry. Yeah, I went to the first column and nothing to change, correct. Then I go to the first row. So first row, this is 0. That means this entire column has to be 0. So I make this and this as 0. And similarly, I go to the this guy and this is 0. So that means I make this and this as 0. Okay. Okay. So and this too also had to be made 0, which is what I did not consider. So I keep an extra flag for first row 0. Right? I just keep an extra flag for that. And the reason for this is because when I was going through the columns and I saw this as 0 and made these as 0, then when I go to the first row, again, I wouldn't know why these are 0, right? And that I don't have to convert these to 0, which is why I'll never update the first row 0 while I go to the first column. I'll do it only at the end. Okay. So that's my sort of approach. I don't know if it's very clear, but let's come to the code and see if we can make it clear there. So coming back to code. So what I'm doing is first I am just going through the entire matrix. So I equals to 0, I feel there might be still some corner case which I'm not fully considering, but okay. Let's see. So if I could, like, should I even go through the first row and the first column in my initial analysis? Should I even go to the first row and the first column? Maybe not. Maybe go to the first one, the first column, and figure out whether the first row should be zero, the first column should be zero. But okay, let's find out that case which doesn't work, and we'll fix accordingly. So first, the basic logic I'm doing is I'm going through each and every. So basically, if any item in the first row or the first column would be zero, let's do it. Okay, so I equals zero, I less than matrix dot length, I plus plus, and j equals to zero, j less than matrix dot length, j plus plus. Yeah, I think the general idea. I want to go back. I want to go back once again to the whiteboard. I think I think the general case that I want to talk about is so while I'm using the first one, the first column as the hinters, the problem there might be something like let's say my array is 1, 2, 3, 4, and yeah, even the problem that I already handled, which is this guy. So how do you handle this? So you go back. So this was 1, 0, 1. No, not this. How about this where essentially this guy 1, 1, 1, 1, 1, 1, 1, 1, and this 0. So you said whenever you encounter a 0, you make the corresponding row and the corresponding the first item of the row, which is this, as 0, and the first item of the column, which is this, as 0. All good. I have no problem with that. And then when you're going through this, you make the entire this as 0, and you make the based on this you make the entire this as 0, and it works. Okay, so this is fine. But if there is a 0 in the first row, the first corner, you might have a problem. And for example, so look at that. It's, let's say, uh, so 1, 2, 3, 4, say 5, 6, 7, 8, and let's say this is 0, 9, 10, 11, and okay, 12, 13, 4, something like this. This essentially means this essentially means that this row and this column should be 0, right? But when we come to this guy, what we would notice is that because of this 0, our logic is, hey, make the first guy of the row and the first guy of the column as 0. So I'll end up making this as 0. And once I make this as 0, now I do the come to the second part of my analysis, where then I say, hey, I go through each and every, go to the first row and the first column. So when I'm going to the first row, I see this is 0, I'll make everything as 0. Right? So basically, don't touch your first row and the first column. As simple as that. Don't touch your first row and the first column. For the first row and the first column, keep separate variables, and only update the remaining rows. And if the first row and the first column is 0, then make them 0. That will be clear. So for example, in this case, yeah, I see this. And based on this, I convert this, which is all good. And now, if because this was in the first column, I will have made this flag called first column 0 as true, right? Now when I'm here, I will go through the, I will not go through this element. I will not even look at this element, essentially. So now I'm going through this, and based on this, I'll make this a 0, and my first column 0, which is why I'll make this a 0. Understood? Understood, I think so. Okay, so let's now solve again. So I'm maintaining two flags. One is called boolean first row 0, and I'll call this false, and then boolean first column 0, and I'll make it also false. Sorry about that. Now I go through each and every element, right? I equals 0, this is this. Now, and anywhere I encounter a 0, so if matrix of ij equals to 0, then what I have to do is, first thing I have to do is the first row, so matrix of I0 equals to 0, and the matrix of 0j is also equals to 0, and if I is equals to 0, then you can say the first row 0 is true, and if j equals to 0, then you can say first column 0 equals to true, right? And yeah, you go through all of these things, and now you do a second pass. First you look at the first anything. Let's look at the first row. So j equals to 0, j is less than, you always start from 1 here. So j equals to 1, j is less than, is it equal to sign? No. So a matrix of 0 dot length, um, matrix of 0 dot length, j plus plus, and at any point if matrix of 0i, sorry 0j, if this is 0, then make that entire column as 0. So for int I equals to 1 is less than matrix dot length plus matrix of ij 0. And similarly do the first column. So I equals to 1, I less than matrix dot length I plus plus. If your matrix of I0 equals to 0, then make that entire row as 0. Matrix of ij equals to 0, and at the end just check if first first row is 0, then start fill matrix of 0 with 0, and if first column is 0, then make the first column 0. Now first column, right? So this, and it's all in place. Okay, let's run, accept it, submit, and it works. All right.